Okay, everyone, welcome back to our statistics class notes. We're here in section 9.2, demonstrating how the central limit theorem for sample means works. We're on page 139. So let's look at example 160, weights of 10-year-old boys. So according to data from the National Health and Nutrition Exam Survey, the mean weight of 10-year-old boys is 88.3 pounds with a standard deviation of 2.06 pounds. Assume the distribution of weights is normal. So now they're actually telling us that our population is normally distributed, okay, and the mean of that population is 88.3. The standard deviation of that population is 2.06. So the weights are normally distributed with the mean of mu, standard deviation of sigma, where mu is 88.3 and sigma is 2.06. Now suppose we take a random sample of 30 boys from this population. Can we find the approximate probability that the average weight of this sample will be above 89 pounds? If so, let's find it, and if not, explain why. Okay, so are the central limit theorem for sample means conditions met? Let's check that quickly. We have 1, a random and assumed independent sample. 2, the sample is pulled from a normally distributed population, so the sample size doesn't matter. However, if it was not a normally distributed population, we have a sample size of 30, which would make it a large enough sample size anyways. And 3, the population is at least 10 times larger than the sample size for sure. So this means that the distribution of sample means is normally distributed with the mean of mu, the population mean, and the standard error is the standard deviation, which is sigma divided by the square root of n. So now our standard error, which is the standard deviation of the distribution of sample means, is 2.06 divided by the square root of 30, which is 0.3761. So we can go ahead and use our StatCrunch normal calculator because we're saying that it's a normal distribution now, because first of all, it's pulled from a normal distribution, and secondly, it would be approximately normal even if the distribution of the population wasn't normal, because we have the central limit theorem for sample means saying we have an approximately normal distribution. This is going to be exactly a normal distribution because it's pulled from a population that has a normal distribution. So I use our StatCrunch normal calculator. This is my results. I'm sure everyone knows how to go get the calculator at this point. Go to Stat, Calculators, pull up the normal one. And we want the probability that x, this is really x bar, but you can't change that, right? Probably that x bar is greater than or equal to 89 pounds. We have to put in a mean of 88.3 and our standard deviation, which we figured out up here, sigma over square root of n, 0.3761, and you get a probability of approximately 0.03 if I round that to 2 decimals.